Bwahahaha! Review for Chapter 8. One hint I want to give you is take notes. Write down the headings because this will be very similar to your test format. The questions will be in the similar order, and if you get stuck, you can look at the headings that you write down, and you'll probably know how to do it. Also, write down little notes to yourself. Don't just write down what I'm doing. Write down a little note to the side in a way that you understand, so that when you get to those questions, you can do well. This test is comprehensive. It's all of Chapter 8. And so even though you've probably been successful with it in my class, most of my students have, it's still a lot of material, and you want to write yourself hints. All right, with no further delay. I'm not going to over-explain these. We've done that throughout the chapter. What I'm going to do is show you how to do each one and try to jot your memory. So identify the characteristics of the quadratic function and its graph. So when it's asking for the characteristics, it's really asking for four things. It's asking for the domain, the range, the vertex, and then is it positive or negative? So looking at the domain, remember the domain is the x values. And so if you look, this arrow is pointing on, indicating that it keeps going beyond this page, and the arrow means it goes on forever. So there's not an x value I could choose that this parabola would not hit, because it goes on forever. It would hit it. And so the domain would be all real numbers. What's the range? The range is the y value, the up and down. Now, it's pointing up, so it goes up forever. Notice that it's not pointing down. It doesn't go down forever. It starts at the 4, the y equaling 4. So it's 4, but it's also going up, so it's greater than 4. So the range would be that y is greater than or equal to positive 4. Okay, where's the vertex? In this case, the vertex, you could just see it. We're not graphing this. It's already graphed for us. The x would be 2. And the y, as we know, is 4. That's the height of the vertex. Remember, the vertex is either the minimum, or if it was going this way, it was a negative parabola, it would be the maximum point. And then is it positive or negative? A lot of students remember it as, is it smiling or frowning? If it's a smile, then it's positive. And those are the characteristics that we can name of this parabola. Now, there could be other characteristics of a parabola. If we were asked to start from the beginning, it may want us to say, is it a vertical stretch or a vertical shrink? But in this case, we really don't have enough data to answer that too much, although it does look like a shrink. We just don't know for sure. So if you know those, you should be able to at least answer the first couple questions, and you have a good understanding of the characteristics of a parabola for sure, or a quadratic. Okay, compare the graph of the function to the graph f of x equals x squared. You may remember f of x equals x squared is also referred to as the parent function because everything else is compared to it. So when we compare it, the first thing you want to look at is the a, or this number in front. If it's greater than 1, it's a vertical stretch by a factor of 4. That's it. It's stretching by a factor of 4. In other words, the parabola is going in, stretching towards this y-axis. It's getting closer to it by a factor of 4. What else can you say about it? Since it's positive, you could say it's smiling. It's positive. So there's a vertical that it's positive. There's no reflections. What else can you say? You could say that if there's anything being added to it, you would say there's a vertical translation, 1 unit upward. So if this was a graph, if this was a parabola, the whole thing would move. If this was it, for instance, it would move up 1 unit. Okay. So what about this one here? Very similar. This one, there's not a vertical or a horizontal unit translation. It's not moving up or down because there's nothing inside like this to move it sideways. All we're doing is this. This is the only thing being done to the parent function. And so that would be a vertical. Now, this number is not greater than 1. It's less than 1. It would be a 0.25, right? But it's more than 0, so that's a vertical shrink by a factor of 4. Remember to keep the headings in there for your own sake so you can not get stuck on it. It says determine whether the function is even, odd, or neither. I think there's 3 questions on your test like this. So they're kind of important out of 20 questions. So how do we do it? The first step is to change the x to a negative. So it's d of negative x equals 2 times a negative x square minus 3. All we did was change the x's to negatives. Then you do the order of operations. What is the order of operations? Should I subtract, multiply, or do powers first? Well, if you remember it as please excuse my dear Aunt Sally, you would do exponents before you multiply. You do multiply before you subtract. So what is x squared squared? I'm sorry, what's a negative x squared squared? It would just be x squared. So we have 2 times x squared minus 3. 2 times x squared is just 2x squared minus 3. We'll bring down this d of negative x. Okay, now what you want to do is see if you can substitute this from anything else that was written. And actually, if you look at the very beginning of the problem, we have a 2 of x squared minus 3, and we have a 2 of x squared minus 3. That means they're the same. So we can substitute this value with what this equals, which is d of x. So we have d of negative x equals d of x. And when you have a negative equaling a positive, that is even. So now we're going to do the same thing with the other one. I think I have a flashcard on this. Let me see if I made one for everyone. I thought I did. I may not. I don't see it. We don't need it, but it might jot the memories of those who are trying to do this. Okay, I don't see it. So, oh yeah, here it is. You may remember that if f of negative x equals f of x, it's even. If f of negative x equals a negative f of x, it's odd. So since this is a d of negative x equaling d of x, it's of this format, it would be even. So I'm going to leave this here for the next one. Okay, you might want to write that down even. That might help you. Okay, so let's do this one. Same thing. Negative 2, but instead of an x, we're putting a negative x cubed minus 4 negative x. And that would be a p of negative x equals. Okay, So let's do the same thing. We do the order of operations. So what's a negative x times a negative x times a negative x? It would be a negative x to the third. If we were to multiply that by a negative 2, a negative times a negative would be a positive 2x to the third. And then a negative 4 times a negative x would be a positive 4x. Now if we look, can we substitute this with anything else? 2x cubed plus 4? Almost. You have a 2x cubed, but it's minus 4. This is a plus 4. So it's not odd, it's not even, it's neither. Let's do the last one. So again, we'll substitute the x for a negative x. And then we'll do the order of operations. Negative x times a negative x is a positive x squared, right? And negative x times 4 is a negative 4x. Can we substitute this for anything? Well, it's not quite the same, is it? I mean, what we could do is you could try to substitute out a negative 1, factor out a negative 1. Then, even then, it really wouldn't be the same. I mean, you could then try to substitute it. Well, let's see what happens. We factor out a negative 1 here. Is this the same as anything? Well, that is the same. Yeah, it just seems to get a little messy, right? I mean, you could have this f of x equal to negative 1 times a negative f of x, but it just seems to get kind of messy when you do all that. Okay, using zeros to graph the function. In order to use zeros to graph the function, you would first put a 0 for the x, and then a 0 for the y, or the f of x. But looking at this carefully, is there anything we can factor out? You always want to look for a GCF, and they actually do have a 3 in common. And then you can factor this one again. Because the difference of squares. Okay. Once you have it all factored, we just need to set them equal to 0. So let's start off by making the y equal 0, or the f of x. So that would mean x plus 3 equals 0. And if you were to take a 3 away from both sides, x would equal negative 3. X minus 3 equals 0. If you were to add 3 to both sides, x would equal 3. And 3 equals 0 is just that's no solution. That's a lie. So we would know that x would equal a negative 3, and x would equal a 3 if the y were 0. So how would we write that? We'd write negative 3, comma 0. Remember, the y is a 0. 3, comma 0. Remember, the y is a 0. So if I were to graph that, I would have 3, negative 3, and positive 3. That was with the y being 0. We need to now try it with the x's being 0. So we'll take the same problem, but the x's will be 0. So it'll be 3 times 0 plus 3 times 0 minus 3. All we did was rewrite this, but where the x's were, we put a 0 in. Because it says use zeros to graph the function. 0 plus 3 is 3. 0 minus 3 is a negative 3. Bring down the 3 unused. 3 times 3 is 9. 9 times negative 3 is a negative 27. So if the x was 0, the y would be a negative 27. So we already have these 2 points from the y being 0, and when the x is 0, we have a 0 and negative 27, which would be somewhere right around here. Now you just do your best to predict the parabola. That's how you would graph using zeros. I think the important thing to remember in this case, we had to factor, take the GCF out first. Then we had to factor again because it was the difference of squares. Once we did that, we had to let the y be 0, so we can get our two intercepts, x-intercepts. And then we had to make the x's be 0, so we could find out what the y-intercept would be. So a little bit of steps there, but that is, I would say this is probably one of the most important questions to get down for the test, because there is, I believe, 4 questions related to this. Okay, some of the easier stuff. Tell whether the table of values represents linear, exponential, or a quadratic function. Okay, first of all, you could just graph these and you could see it right away. I want to do it without graphing though, but you could do it with graphing. So you can see that these are increasing by 1. The x's are plus 1 each time. So really what we care about is these y's. I can see that it's going down 2. 3 minus 5 would be a negative 2. 1 minus 3 would be a negative 2. A negative 1 minus 1 would be a negative 2. A negative 3 minus a negative 1 would be a negative 2. And since it's the same on top as it is on the bottom, there's a constant rate of change. We're adding the same number and we're subtracting the same number each time. It's linear. What about this one here? Well, we're doing a plus 1 each time. And if you look here, we're multiplying by 2 each time. If you're multiplying by the same number each time, that's exponential. So linear is when you're adding and adding, or adding and subtracting. Exponential is when you're adding and multiplying or dividing. Okay. Find the zeros of the function. This is really simple. To find the zeros, you just basically take the opposite of what these x values, whatever in the parentheses. So if there's a plus 2, it would just be a negative 2. If it's a negative 1, it would be a positive 1. Okay. You'll get a couple questions like this, and they're just really easy. I did want to show you other examples where you can't just use that shortcut of just taking the opposite when it says find the zeros. But there is questions like this on the test, and you can just get them quickly. But if they have a number in front of the x, you can't just take the opposite. I think that's supposed to be a plus 1. You can't just take the opposite of the numbers. Like this won't just be a positive 1. So what you have to do is actually set them equal to 0. 2x minus 1 equals 0. And then 3x plus 1 equals 0. And then you just solve for x. Same on this side, just solve for x. So room to write here, x equals a negative 1. So that would be the answer to this one. And then I want to show you, sometimes you can actually have 3 answers. I don't have a lot of room on this page. Let me see if I can grab another sheet here. Let's do that last one. I'll just kind of move it. So on this one here, be careful. It's a difference of 2 squares. So it'd be, this would turn into x plus 4. x minus 4. This would be an x minus 3. So then you can set them all equal to 0. Because it says find the zeros of the function. So this would be a negative 4, positive 4, and 3. So it's not hard, but be careful with the factoring. Watch out for that. Whew. Okay. Find the vertex and axis of symmetry of the graph of the function. Okay. So in order to do this, you want to know what form it's in. Is it in intercept form? Is it in vertex form? Or is it in standard form? So looking at this, it's in standard form, right? Standard form is that. Let me just write it because I didn't have a card with it on it. It's y equals ax squared plus bx. Oops, can't see it. Plus c. So this first one's in standard form, right? F of x is like the y, equals is like the equals, a is like the 2, and so on. And so when it's in standard form, how do you find the axis of symmetry? It's negative b over 2a. That's how you find the axis of symmetry. So a negative b would be a negative, and then the b is a negative 4. So it would be a negative negative 4 over 2 times the a, and the a is a 2. So in this case, it would be a 4 over 4, which is a 1. So the x value of the vertex, or the axis of symmetry, is 1. Now you need to find the y value, or the height. How do you find the height? Is you substitute the axis of symmetry back into the original equation. Once you do that, it will tell you what the y value is. So let's just do that. It would be a 2 times 1 squared minus 4 times 1 plus 1. Doing the order of operations, we should square first. I can see I'm running out of room here, but so 1 squared would be 1, and then 1 times 2 would be a 2, and then 1 times a negative 4 would be a negative 4 plus 1. 2 minus 4 is a negative 2 plus 1, be a negative 1. Okay, that's how you do it once it's in standard form. What if it's not in standard form? What form is this one in? Does that look more like vertex form? Or does that look more like intercept form? Well, it looks more like intercept form, right? It has the 2 sets of parentheses. It has a in front, or a number in front. So how do you find the axis of symmetry when it's in intercept form? P minus Q divided by 2. So the P would be you take the opposite of that. So it would be, because it's a negative P, so it would be a 1 minus 7 divided by 2, which would be a negative 6 divided by 2. I just realized something really quick. It's actually P plus Q divided by 2. So that would be an 8. Sorry, I get comments. That would be an 8 divided by 2, which would be 4. So the axis of symmetry didn't feel right when I was doing it. Sorry. It would be 4. And so if the axis of symmetry is 4, how would you find the vertex? You would substitute a 4 back in and see what you have. We can do that real quick. 3 times 4 is 12. 12 minus 1 would be 11. 2 times 4 would be 8. 8 plus 7 would be 15. And you can see we're getting a pretty big number. So you'd have 11 times 15, and half of that. Anyway, it's a pretty large number, so we won't write it this time. What about this way? What form is that in? It's in vertex form. Okay. And the vertex form is probably the easiest because you just take the h and the k. The h is a -2, but since there's a negative in front, you write a +2. The k is a 3, so it's 3, and that's just simple. That's just done. That's easy. Okay, tell whether the points appear to be linear, an exponential, or a quadratic function. There's lots of ways you can do this. We actually did this earlier, even in this review. But I think when it's like this, I like to graph it. I mean, you could set it up. Let's see, there's one that's a little challenging to graph, 4 and 14. So I count by 2's. Maybe I'll do that for the y's. So x is -3, and y is -14, 2, 4, 6, 8, 10, 12, 14. -3, 14, there's your first. The x is a 1. The y is a 2. Remember, I'm counting by 2's. The x is a 4. The y is a 14. 2, 4, 6, 8, 10, 12, 14. I mean, what is that looking like so far? It looks like it could almost be linear, right? But it could curve on me. Let's see. If x is a -2, y is a -10. 2, 4, 6, 8, 10. And if x is 0, y is -2. So you can tell that this one is linear. Try to hide it by the order they put it in, but it's linear. Anyway, I went over a lot of material quick, and hopefully, though, that it helps you guys do well in the final. You've worked very hard. I want you guys to do well, so good luck.